All right, on to part 2. We are now in section 7.4 and 7.5 with sine and cosine graphs. So we're going to read these graphs and define each of the parts of them. So question 15, we have this one graph and they want us to find the amplitude to start off. So remember, with the amplitude, we take the high minus the low and then divide by 2. So that means our high is 3, our low is at -1. Divide that by 2, we're going to get 4 over 2, which is just 2. All right. Next, we want to decide if there's an x-axis reflection. So knowing whether that's a sine or cosine graph is going to help us here. So when we cross the y-axis, notice that we cross with that midline point. So there's kind of 3 options we typically have when we cross. Is it through a max, a min, or a midline? And because it's through that midline, we know that we're going to be dealing with sine. But remember, the general sine equation graph of it ends up, instead of starting going downwards, it starts by going up. So that means since our graph is going down, there will be a reflection. Next, we want to find our period. So if we start at this point here, we go 1 full rotation. Let me redraw that. 1 full rotation to 2 pi. So 2 pi will be our period there. And then our midline is going to be this midpoint. I'll erase that at 1. And that midline is going to tell us what our vertical shift is, which is a shift up 1 unit. So to put it all together, y is going to be equal to, so we have our amplitude, but we also have the reflection, so it'll be -2. We decided it's sine. Now we need to find our b. So remember that our period is equal to 2 pi over b. So since our period is 2 pi, that means that our b is going to be equal to 1. So that'll just be x here. And then finally adding our vertical shift is just 1. All right, on to question 16. So we're going to find the amplitude, the midline, and then the domain and range. So the amplitude is always going to be the absolute value of this value at the front. So our amplitude is going to be 4.2. And our midline is always going to be that vertical shift. So our midline is y equals 1.1. And remember, since it is a midline, we need to have the y equals, not just 1.1. All right, so as for the domain and range, so for the general sine function, our domain is, domain is typically -infinity to +infinity, and then our range is -1 inclusive to +1. So it's the max and min values that our sine function can be. So now knowing our amplitude and our midline, which are all vertical, they're all vertical transformations, we can redefine our domain and range for this new function f of x. So since these are the amplitude and the midline both affect the function vertically and not horizontally, our domain is going to stay the same, but our range does change. So we know typically we're gonna have that -1 to 1, but we want to apply our 2 transformations here. So the first thing to apply is the stretch, right? So we'll take -1 and 1, and they're going to go to, well, let's multiply by -4.2. So we'll get 4.2 and -4.2. Oh, 4.2. All right. So I'll just say times -4.2 there. And then our last step, we want to apply that midline, so that vertical shift. So we're going to add 1.1. And so that's going to give us 5.3. And then -3.1. So finally, to put our answer together, this will be, the negative is going to be our lower bound. So we'll get -3.1 all the way to 5.3, and that'll be our new range for this function. Question 17, we have the hottest day in the last summer had a high of 103 degrees Fahrenheit and a low of 69. And so those highs and lows are going to be helping us find the amplitude for this question. And we can model it with the sine or cosine function, and t represents the time after 3 a.m. All right, so the first thing we need to do is decide whether we're using a sine or cosine graph. And so as I mentioned earlier, sine starts at a midpoint, cosine typically starts at a max or a min. And since we're starting at a minimum here, I'm going to use cosine so that we can avoid having a horizontal shift, so a shift of 0. And because it's starting at a minimum, we know that it's going to be negative cosine. Because positive cosine typically starts at the maximum, right? That positive one versus the negative one. All right, so our amplitude here is going to be the same formula as before, our high minus our low over 2. Plugging that into your calculator, you should get 17, which will also be the value of A. And then next we have our period. So looking at the graph, you can see at 0, and then the next time we get to that point is roughly 24. We also know that it's throughout the day, so 24 hours. So our period's 24 hours. As for the value of b, remember period is equal to 2 pi over b for our sine and cosine, which means that our b is equal to 2 pi over 24, or to simplify it, pi over 12. And then finally, we need our vertical shift, which is also our value of k. So that's our midline. And so our midline is going to be equal to our minimum plus our amplitude. So that's going to be our 69 plus our amplitude of 17 to get our final answer as 86. Now to finish it off, we have y equals, remember we said it was a negative cosine, so we're going to get negative 17, 17 being our amplitude. Cosine is our function. B is pi over 12. Variable is t. We want to remember to keep that there. And then finally our midline is going to be that plus 86. So there we go. Question 18. We want to find the equation of the line that intersects the x-axis at this angle of pi over 3. We also know that we're going through this point 5,6. So remember that our slope m is going to be equal to tangent of theta in this case. And so our tangent of pi over 3, remember tangent is sine over cosine. And so looking at our unit circle, we can see that sine of pi over 3 is going to be root 3 over 2. Cosine of pi over 3 is going to be 1/2. And so we're going to get root 3 as our slope there. So here m is equal to root 3. All right. So now we also need to find the y-intercept and the equation. And so I'm going to do kind of 2 steps in one. We're using our point slope formula. We're going to get y minus our y1, which is 6. And then our slope, square root of 3x minus our x coordinate, which is 5. We get y equals square root of 3x minus 5 plus 6. And then to simplify, we get root 3x. That's our slope, remember? And then we're going to have 6 minus 5 root 3. This is going to be our b. So we have b is equal to 6 minus 5 root 3. And then finally, they want us to write the equation of the line with parameters rounded to 2 decimal places. So plugging those into your calculator, you will get about 1.73x minus 2.66. There we go. Question 19 gives us a tangent function that's been transformed in a couple ways. So they want us to describe the different ways that it's been transformed. So right off the bat, since we're going through the origin still, we know that there's not going to be any shifts, so no shifts. But there is going to be both a horizontal and a vertical compression, and we can see that there is a horizontal compression because our period is now pi over 2. And remember, typically for tangent, we typically have period equal to pi, right? It's 2 pi for sine and cosine, pi for tangent. And so our period has now changed from pi to pi over 2. And so remember, when we have a stretch of compression, it's going to be that value is going to be 1 over b, or absolute value of b. And so to find our b, we know that our period is equal to pi over b. Since our period is pi over 2, that means our b is going to be equal to 2. So we have a horizontal compression by a factor of 1/2. And that's because it's a compression by 1 over b. B is 2, so we're going to get that 1/2 there. Now for the vertical stretch or compression. So remember, typically this point here for tangent functions is pi over 4, 1. Now the pi over 4 is now pi over 8 because of that horizontal compression. The 1 going to the 6 is because of a vertical stretch, so it's stretching by 6. So we have a vertical stretch or by a factor of 6. All right. On to question 20, we want to sketch a graph, a transformed tangent function with vertical asymptotes at these values of x's, passing through the point 0, 1, and then 0.5, -3. And then we can use that graph to find a possible formula. Actually, back to 19, forgot to write the formula. So just putting everything together, we had a vertical stretch of 6, so that's going to be number out front. And then that horizontal compression, I remember our b was 2, so we're going to get that 2x, and then no shifts. So that'll be our formula there. All right, back to 20. So let's go ahead and start trying to graph this. So we know -3, -1, 1, and 3, we have those asymptotes. So we'll get 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, and then I'll say 1, 2, 3, 1, 2, 3. So this will be our x-axis, our y-axis. So drawing those asymptotes, something like this. All right, now onto our points. We know we have 0, 1, and 0.5, -3. So 0, 1 means we're going to have a vertical shift, and then that 0.5, -3, so we're about halfway down here. We'll similarly have a point up here. And so because we've now flipped, we can kind of see that this tangent function is going to have a negative out front. That was kind of bad. Let's do that. So it's going to be shaped somewhat like this. All right, so as for writing the formula, we have a few things that we need to find. So we mentioned before the 0, 1 is going to be telling us where our vertical shift is. This point here is telling us that we have a vertical stretch. And then lastly, these asymptotes are telling us our period. So our period here is going to be, so between 1 and 3, we have a period of 2. Remember, that's pi over b, so that tells us that b is going to be equal to pi over 2. So to throw it all together, we're going to get y is equal to, so let's see, we're at -3 here. So we're going to get -4 tangent of our b, pi over 2x, and then plus 1 for our shift. And remember, it's -4 out here because our typical point is pi over 4 positive 1. Positive 1 to -3 is going to be subtracting 4, so that's why we have that there. There we go. Now on to the last page for the part. So name any two of the vertical asymptotes of this graph. So the asymptotes can be found by finding the period. Because we have no shifts, we know we're going to be centered at the origin. So that means that graphically, the distance between the two asymptotes here is going to be equal to our period, and so this will be half of that. So remember that our period is equal to pi over our b, which in this case is 1/6, which this is the same as 6 pi. So that whole length is 6 pi, not 64, 6 pi, which means here we have 3 pi and -3 pi. And then to find other asymptotes, we can either add 6 pi or subtract 6 pi. but we want the interval between 0 and 10 pi. So that means 3 pi is going to be one of our answers. Add our period, which is 6 pi, we'll get another one, 9 pi, and those are 2 of our answers. On to 7.7 now, and we want to simplify these expressions. And so for tangent of theta times cosecant of theta, let's write them in their base sine and cosine versions. So tangent is sine of theta over cosine theta. Cosecant is 1 over sine of theta. So notice these will cancel out. We'll be left with 1 over cosine of theta, which we can also write as secant of theta. All right, next we have cosine of x plus sine of x, and that whole thing's squared. So to start off, I will go ahead and FOIL that out. So we're going to get cosine squared of x plus, and we'll end up getting 2 sine of x cosine of x. And then finally sine squared of x, bringing that negative 2 cosine of x, sine of x down. And now notice these are the same term, just have a different sign. So those are going to cancel out. Then we're left with cosine squared of x plus sine squared of x, which by our identities, we know that is going to be 1. So that'll be our final answer there. All right, next, we're given an expression for sine, and we want to find cosine and tangent along with that. So remember our triangle here. We have this angle theta. Sine is going to be the opposite over hypotenuse. So if we divide both sides by 4, we're going to get sine of theta is equal to x over 4, which means x is going to be our opposite, 4 will be our hypotenuse. And to find this adjacent angle, we know that 4 squared is equal to x squared plus, let's call it just b squared for now. Just call it b. And to solve for b, 4 squared, subtract x squared from both sides, take the square root, so that'll be our answer for b. So cosine is equal to adjacent, so our b, and I'll simplify that to 16 since 4 squared is 16. It's going to be b over 4, and then finally tangent is opposite over adjacent, so our opposite is still x, our adjacent is b, and there we go. And on to the last one. We want to use identities to find the exact value of cosine and sine. So remember with that triangle again, tangent of theta is equal to opposite over adjacent. And so our c squared is going to be equal to 5 squared plus 2 squared, which is equal to 25 plus 4, which is 29. So c is equal to the square root of 29. So now to find the exact values of cosine and sine, cosine is going to be our adjacent over our hypotenuse, square root of 29, and sine is going to be equal to the opposite, so 5 over our hypotenuse. Now the next thing to check is whether the signs, so if it's positive or negative, are correct, and we can decide that based on this interval. So we're going from pi to 3 pi over 2. So if we think about our unit circle, well, here we have pi, 3 pi over 2. So that means we're in this third quadrant here. And what do we know about sine and cosine in that quadrant? Well, they're both going to be negative. So our final answer should actually be the negative version of these. And there we go.